All right, well, welcome back. We're going to be talking about how to find areas of find the volumes of solids using cross sections in this video. I'm using a 2003 example from a AP free response question. And here we have this is a question number 1 from that section. And I added some other different parts in order to solve this. So let's go through and just check out how you would do this. So first off, we're given a region R, which is bounded by a graph of the square root of x. So here's the square root of x, y equals the square root of x. And we have good old e to the negative 3x power right there. And we have a vertical line here at x equaling 1. And now what we want to do is we want to figure out, using the region R as the base of the solid. So this is our base. And for the solid, each cross section perpendicular to the x-axis is a square. So we're going to start with this one. It's a square. So if you watch my other video, in order to figure this puppy out, is we need to kind of imagine and look at our picture. And we're taking this and we're taking it and creating a cross section. Now, each of these cross sections is going to be different. In order to figure out the volume of these cross sections, we have to figure out the integral from A to B of the area of the cross section in terms of x and then dx, okay? Because we have perpendicular to the x-axis, so we're going up and down. So these are going to be in terms of x. Now, the first one is a square. So what is a of x going to equal? Well, that's going to be the side squared. So what is the side length going to be? Well, this side is going to equal this. And then what we're doing is we're creating little squares, and they're all being placed inside here. So all these sides are equal. So the question is, what is the side length in terms of x? Well, you take the top minus the bottom to find the length of something. So we're going to take, in this case, the square root of x, and we're going to subtract that from e to the negative 3x. All right, and that's going to be that, and we're going to square it. That is going to be our side in terms of x squared, and that's what we have there. So s is going to equal the square root of x minus e to the negative 3x power. So how do we write out this equation? Well, I'll just make this in blue ink right here. So we're going to integrate. Our limits are from here. All right, so we got to find a point of intersection. All right, so to find this point of intersection, we're going to set the square root of x, all right, equal to e to the negative 3x right there. We'll have to use our calculator for that. And we're going to 1. So I know the upper limit's going to equal 1. We'll find out this one by using our calculator. So if you take out your calculator, and so I have my calculator here. So let's just take the square root of x and put that in our y equals. And then we'll go into y2, and then we'll go have e. All right, and we'll raise that to the negative 3x power. All right, I'm going to go zoom 6 right here, and we can kind of graph this. And you can see there's our first graph, and you can see our second graph coming in like so. And the second, now it's coming. There it is. And it's really zoomed in there, but we're going to find this point of intersection right here. So we're going to second calculate, and we want to find intersection 5. And I'm going to go first curve, second curve, guess, and then it's going to give us an answer, hopefully. And we have 2.387. So 2.387. Now I'll just bring that right there, just so we can see what that's going to be. All right, so 2.387, we're around the 4 decimal places. So, or say 0.2387, and we're going to use our a of x. So a of x, our area, we found out to be the square root of x minus e to the negative 3x power. All right, squared dx. And that is our equation to find the volume of solid if our cross sections are squares. We can plug this into our calculator, all right, and we can find out our answer. So if you go over here to your calculator again, and you want to punch this in, you can second quit right here. We'll clear that. And so we're going to take go second, oh sorry, not second. You just go to math, and you go down to 9, which is function integrate. We're going to go from not negative, all right, 0.2, all right, 387, and we'll go up here, and we're going to go to what that appears to be 1, and then we're going to have our value, which is going to be the square root of x. We'll probably want to put parentheses in there. I apologize. There we go. And one more. All right, put parentheses. And now we're going to go to square root of x. We're going to go minus, and we have e to the negative 3x power. We'll close parentheses again, and we're going to square this. Okay, put our x value there, and we're going to press enter. And there is our volume. Okay, so that's our volume right there, and I'll put that right there, and so you can see what that would be. Okay, and so that is the volume that we would receive for our first, all right, type of equation. And so I'll put that in 0.3109. You only need is 3 decimal places for AP Calculus, but you can round a little bit farther if you want to. Now what happens if we switch this up and make circles? Circles. Well, if we do circles, what happens is that now we no longer have a side of a square, but now we have a circle coming around like this, okay, coming around like so. Well, how do you find the area of a circle? Well, that's going to be pi r squared, pi r squared. The radius is actually this from here to here is the diameter. And so really we want to find the radius. And how do you find the radius? Well, the radius is going to equal the top minus the bottom, and we're going to divide that by 2. All right, so when we integrate this, everything else is the same, 0.2387. We're going to go from 1, and we have pi. Pi is our equation, or the constant. We'll put that out there. Now, what is going to be squared? Well, instead of just having the side, it's going to be the square root of x minus e to the negative 3x, and all of that's going to be divided by 2, okay? And we're going to take that quantity and square it, and we'll have dx out here. Going through the same thing, we can find this using our calculator. Just to save time, you can do that, but that's how you set it up. See, now when we go through the next one, we can see that if we do quarter circles, well, this changes up things again, because no longer, all right, is this maybe, all right, a diameter, okay, what we're looking for here. I'm looking for a radius, and this is a quarter circle. And so if you know what quarter circles, this is our radius. So this length is our radius. And so I'm going to get rid of this 1/2 there, because now in order to find a quarter circle, the area is going to equal, all right, 1/4 pi r squared, because that's a quarter circle. Knowing this, I'm going to have pi over 4 as my constant. We're going to go from 0.2387, because that hasn't changed to 1. But now, what is our r? Well, our r is actually the length from the top minus the bottom. And so really, it's going to be the square root of x minus e to the negative 3x. And that quantity is going to be squared, dx, if we have that. So you can see each of these integrals change depending on what this length is and what our equation of our area of our cross section is going to equal. Well, let's say we go one more step farther. Well, how does this change again? Well, right here, we no longer have radiuses. We now have sides of a right or equilateral triangle. And so each one of these sides are the same. Well, what's the equation of an equilateral triangle? The square root of 3 divided by 4 times the side squared. Well, once again, what is this length? Well, this length is the side. All right. And so that's going to equal what we have in previous problem. So we're going to have square root of 3, 4, because that's the constant of our equilateral triangle. We're going to go from negative 0.2387 to 1. But now we're going to have our side squared. It's going to be square root of x minus e to the negative 3x squared dx. You can see that is once again our value. Now, last one, a little bit more complex, is now we have a rectangle whose height is 5 times the length of the base. So, a rectangle. A rectangle, if you recall, is base times height. Base times height. Well, the base is actually equal to this length here. And so our rectangle, we know it says the rectangle whose height is 5 times the length of the base. So whatever this is right here, it's going to be 5 times bigger than whatever the base is. So these are not the same length. It's not a square. And so, all right, in order to figure this one out, yeah, we're going to go through the same thing. We're going to have 0.238, 7. Okay, we're going to 1. Well, our base length we know is going to equal the square root of x minus e to the negative 3x power. But now because that's our base, our height is going to be 5 times that. So we're going to take 5 times the square root of x minus e to the negative 3x power dx. If you wanted to simplify this, the 5 is a constant, 5 can be taken out. We can go from 0.2387 to 1, and now we see both those values are squared. So we have square root of x minus e to the negative 3x squared dx. Doing a little of our math, we can solve that. All right, and so I hope this helps you out in realizing that when you go through, it is important you really do identify what is the area of the cross section. Figure out the equation of that by looking at your picture, okay? Identifying what is that length using a little algebra, top minus bottom, or right minus left if you're going with respect to the y. Find your limits of integration. Might have to use a calculator to find the intersections. All right. But once you have that, plug it in or solve it by hand, you integrate. Okay. We just square, a circle, a quarter circle, equal a triangle, and then a rectangle. All of these things you're very well capable of doing. But once again, it is knowing what is the area of the cross section that you're using. All right. Well, I hope this helps you out, and good luck and God bless in the rest of your problems.